All right, welcome everyone to our panel conversation. The topic is open source dependency health towards maturity and sustainability risk assessment model. My name is Georg. I'm your facilitator today, and we are excited to talk with you through a novel risk model that we've been working on. First, a quick round of introductions. We have Anna, who is a project manager at the Linux Foundation To-Do group, which is a collaboration of open source managers with the mission to create and share knowledge and best practices. One of Anna's achievements when she was working on her Master of Science, her thesis was on DevRel in open source. Wietse is a senior manager and area lead of the global engineering at ING and responsible for the global CI/CD setup. The platform that they're working on is Azure. And to give you an idea for the scale and complexity, ING has 12,000 engineers, 80,000 repositories, and 600,000 pipelines per week. Miguel is data scientist at Bitergia and passionate about open source. He works with open source program offices, foundations, and many different organizations. And his master thesis was on discovering bot behavior using machine learning, or we would call that now AI. I'm an open source strategist and director of sales at Bitergia. My mission is to help open source become more professional in the way that we use community metrics. For this, I co-founded the Chaos Project, where we define metrics around community health. And my PhD was on corporate engagement in open source. To kick off the panel, I'm going to ask Anna, as a project manager of the To-Do group, you have this view across organizations and trends, and you can see the increasing complexity of the software supply chains and open source role in this. Can you share and give us an overview of these trends and the emerging solutions?
Yeah, so absolutely. So actually in my day-to-day work, I had the pleasure to work with a lot of organizations that has open source program office or open source management. And the recent trends that we have been seeing right now are around how can these open source center of excellence and managers working across organizations do to help on open source supply security that is directly directed with the project health and how to build more, like how to tackle this project health of the projects. So I've seen, I will say, three main challenges happening right now from these open source managers that are seeking. One is around tooling, like developing or finding or building tooling that is capable to identify, to detect vulnerabilities in terms of open source project health. The other one is about building processes capable also of understanding which projects does have those vulnerabilities, which projects needs help, and how they should be providing help in terms of infrastructure, in terms of money, and so on. And I think this main two core will be done. Like, it's around tooling and also finding effective ways to understand which projects are the ones that are having these vulnerabilities and how they should be tackling those challenges.
Thank you, Anna. Now, moving from this broad context that you just shared, I'm moving on to Wietse. As the area lead of global development at ING, you're thinking a lot about how to actually do this management of risk in your specific context.
Correct. Well, we thought we were doing well. We have a lot of engineers, so we have a lot of processes set up around SCA scanning, a lot of compliancy risk models. But our story kind of started when Log4j happened. We all know that one, the Log4Shell issue. All hell broke loose within a company with 12,000 engineers. Where are we using it? What part is affected? And we could, with some help of some smart engineers and the team, we could pretty quickly figure out where the issue was. But when that was solved, we got a creeping feeling. What if? This was an easy one. There was a community supporting Log4j, and the fix was there quickly. We got the brewing feeling that we only saw the fluffy tail of the big beast underneath. And we started thinking and theorizing, what if this was a library that was used everywhere in a company and there was no community? Or the community was not able to fix this one? What impact would that have? So we started discussions with our architects, with some industry leaders on, can we measure this risk? Is this a risk that's really true? Is it there? Luckily, we stumbled upon the guys from Bitergia for help to do some investigation into this risk that we foresaw.
Thank you. Yeah, let's talk about that. Miguel, you're a data scientist at Bitergia and been working on this solution. What is the general conception behind how you approach this problem of looking at the risk from the community perspective? And I know we have some slides, so we're going to rearrange for a moment so you can see the slides better.
Yeah, I think it's better if we support this with slides. Okay, yeah, so to explain a bit the approach we took for this, basically, well, we are talking about risk, so we need a definition for risk, right? So we are talking about the risk in the sense of, it's a threat. Oh, okay, thank you. There's a risk which is a threat to the success of the project, but which hasn't happened yet, right? So when we talk about risk in open source dependencies, we can talk about many aspects. We can measure many aspects. Vulnerabilities, there are known and unknown ones, licensing thing, and maintenance issues. So in this case, we wanted to focus, so we assume that we don't know the vulnerabilities that are happening in our open source projects, right? So the idea was to use the maintenance issues and take the code smells idea and take that to the community smells to enhance this concept. And you assess these community smells in order to identify projects that could have issues in the future. So that was the main focus. So how we did this is to choose 7 metrics that assess project health from the chaos group. That includes measuring lead times, growth of contributors, BMI, etc. And then we aggregate the values of these metrics and the results into one score over 10. For each dependency, what we have is kind of a traffic light value, red, green, red, yellow, green, and then we can have one score per dependency, right? With ING, in this case, we produce a proof of concept, and we enhance this model by adding also the dependency information from the software components they come from. This allows us to aggregate the data by software components, so we don't only know this data by dependency, but we know also how many software components are affected by this risk. And to show you how this looks, this is a dashboard. We prepared some real data from the Kubernetes project. So we analyzed the dependencies from Kubernetes project. And what you can see here is an overview and explain what each part shows. So in this case, we are filtering by a subset, which is the Golang dependencies from Kubernetes. Okay. And at a high level, we see this distribution with the number of dependencies depending on the risk where they fall in this traffic light analogy, right? And in this case, we have low, medium, high. And in this case, we also separated that in very high. I explain that what happened in a minute. Also, we have this heat map that helps us to identify where the problems may be happening or where the projects are shining. So this makes more sense right now. So we can also drill down to the specific results in the dependencies, and we can understand how the score was calculated in this case. So we'll give an example. This is another separate dashboard to get specific results. So if this dependency, we We have, it has a medium total risk and 4.9, so we can focus on this table, see the individual values of all the metrics, and we can see that the risk is medium because there are two high risk metrics, in this case related to the lead times. So this could mean the project is slow, reviewing, I mean, it's slow closing issues, it's slow reviewing code contributions, and we know that something's going on and we can review what happens there, right? We can have a closer look and it gives us a starting point at where to look at. So I explained that we analyzed the Kubernetes dependencies. So what did we learn about this analysis? We see this distribution and we see this first high bar. Basically, when we don't have enough data to compute the metrics for the model, it means that there's no activity. So that by default means there is a risk because the project has no activity at all. Okay, and then we can say that mostly 0.5% of the projects have a low maintenance, right? And the other 0.5% seem to be okay. Looking at the heat map distribution, in this case, if we focus on low-risk dependencies, we see a pattern here. They seem to doing really good at maintenance, so they have really good maintenance values. But even if in low-risk projects, we see this problem that they rely on too few maintainers. If we look at the pony factor metric, it's looking at how many contributors are responsible for 0.5% of the code. They depend on one or two contributors, so that's risky, right? And that's happening even in low-risk dependencies. And that was a brief explanation of how the model works and the approach we took for this model.
Yeah, thank you. Let's get back into our panel configuration. We'll change the setting. And then I'm going to hand the microphone back. So check on time, we are doing great. So thank you for sticking within our script. Wietse, we developed this proof of concept with you, and what have you seen? What were the initial reactions? What insights were you able to gain from it?
Sadly, a bit scared, because this was against Kubernetes, but we of course also ran it against some of our own repositories. These were not allowed to share because compliancy, being a bank and finance. And we found quite a few projects that are dependent on libraries that haven't even been supported for the last 6 years. And that was only within our own organization with our own developers. And then taking it into account into having 12,000 developers, I think we hit something that at least requires the attention. Because if you know that a library is not supported well, you have the choice to either join in, sponsor, or look for alternatives. But at least then you know that you have the issue. And just with the 9 repositories that we used and calculated dependencies of using the graphs of Miguel, it already showed us that we're onto something that, yeah, is worth investing and taking a bit deeper dive into and compare. Yeah.
Yeah, thank you, Wietse. Passing on to Anna, given your industry experience and look really across the big picture, how do you see this kind of looking at risk, this risk model and its place in the landscape of solutions?
So taking a step back on the challenges I mentioned earlier, I think it covers a really interesting need of organizations that said, okay, I understand that these are the dependencies that are on risk, but this is a more complex and detailed overview on from these dependencies, like where, like it really answers this where, and it will help also open source specialists to see like how they can help. Is it something that needs to, for instance, there are low participants and people maintaining, or is it more related with the efficiency on how are they solving issues, or how are they closing pull request? Because the kind of help they can support is going to be completely different. And there was a challenges all the time in the two-to-group conversations that it's about, okay, I understand there are vulnerabilities, but I really need to know, and for that you need data, you need metrics, where. And this way, maybe the OSPO or the open source manager in charge can better know how to support, and also thinking about how can they transfer, like communicate this to the managers and get this manager level support. They can see, hey, this is, you mentioned that it was scary at the first time, but I see this also as a really great opportunity to say, yes, this is scary. We should be investing more in that, and gives a lot of value and gives evidence to start to management.
Thank you, Anna. We are in our last final round of questions, and now we have seen what is possible with this proofs of concept. Where do we go from here? What do we do next? Miguel.
Okay, is this on? Okay, is this working? Yeah. Okay, yeah. Well, first of all, I think it's really exciting to participate in such an amazing project and collaborate on this and produce this value to a company as important as ING. I think the main challenges we have, you will maybe comment more on that, but scaling up this analysis is a big challenge for us, especially in a large corporation as ING, right? Also, there are another lines of work, for instance, considering more metrics to augment the model, taking into account these digital sovereignty metrics, metrics related with organization participation. So these kind of metrics can also provide some value on what's going on these dependencies. Yeah, so also to get more accurate SBOMs, because SBOM analysis is really complex. So we discovered that and we proved that. And we will keep advancing on that. As a data scientist, I feel like I'm a playground with this. So yeah.
Yeah, thank you, Wietse.
Bit of the same. It generates more questions. Our main stakeholders in vendor management and asset management, they also want to have a chat with them now about licensing, and especially licenses changing to business licenses, Terraform, for example, Elasticsearch. That has quite financial impact on a big institution. So that's also something to keep in mind and maybe add as a risk. But the first things we need to tackle now, the first one was SBOMs, getting a good SBOM of someone else's software that doesn't have an SBOM. Well, we were able to get SBOMs that were effective enough at least to do calculations on now. But the first big thing for us now is scaling up. We ran it for 9 repositories. Works pretty well. The outcome is nice, the presentation layer, perfect. But we need to scale up to 80,000 repositories to scan them on a at least monthly or bi-monthly basis, and that needs some work. So we'll be helping out and joining in that one.
Thank you, Wietse. Anna.
Are these like last thoughts?
Yes, last thoughts. Where do we go from here? What's next? Where do you see the future?
So I think this can set the ground to get evidence within its organization's like structure, because no organizations are the same. And maybe setting the ground to say, okay, we have thousands of this, and we now have the power to see them. So where can we invest talent to tackle these challenges? So we can maybe scale up these open source efforts within the organization, and can be a starting point to can work with some organizations, taking it from the risk angle, but with more evidence, and can get a good tool or mechanism to show this evidence and to grow investment on this open source talent.
Thank you. Yes, so what you've seen today is something we are working on. A lot of this is coming from the Chaos project around metrics. The tooling is all open source. So happy to have you be part of that journey if you're interested. Thank you so much to the panelists for sharing your experience with us today. Thank you to the audience for being with us today, and we'll be around for questions.